So you've probably heard a lot about AI that creates things. You know, the kind that can write a poem, generate a wild image of an astronaut riding a horse on the moon, or even compose music. That's called generative AI, and it's been getting all the headlines. But there's another side to artificial intelligence, one that's been quietly working in the background for years, making our devices smarter. This is non-generative AI. Think of it less like an artist and more like a super smart analyst. It doesn't create new stuff from scratch. Instead, it looks at the data you give it and makes a decision or a prediction based on what it sees. Its main job is to understand and classify information that already exists. It's the detective of the AI world, not the painter. You show it a million pictures of dogs, and its goal isn't to create a new, never-before-seen dog. Its goal is to get incredibly good at pointing to a new photo and saying, with near-perfect accuracy, "Yep, that's a dog." It's all about recognition, classification, and prediction. This type of AI is built to find patterns, identify objects, and sort things into categories. It's the foundational tech that powers so many of the smart features we use every single day, often without even realizing it. Let's break it down with a simple analogy. Imagine you have a massive, unorganized library with millions of books. A generative AI might read all the books and then try to write a new one in the style of your favorite author. A non-generative AI, on the other hand, would be like a master librarian. It would read every book, learn to identify the genre, author, and subject of each one, and then organize the entire library perfectly. When you come in looking for a mystery novel set in the 1920s, it doesn't write one for you. It just knows exactly where to find it on the shelf. It analyzes and categorizes, making existing information useful. This distinction is super important. While creating new content is impressive, the ability to analyze and understand the world around us is arguably more integrated into our current technology. This is the workhorse AI that makes our phones unlock with our faces, helps our email sort out spam, and guides navigation apps to find the fastest route. It's focused, practical, and incredibly powerful. Two of the best examples of this in action are convolutional neural networks, or CNNs, and the You Only Look Once algorithm, better known as YOLO. These two are superstars in the world of computer vision. First up, let's talk about CNNs, which stands for convolutional neural networks. That sounds complicated, but the core idea is actually pretty straightforward and inspired by how our own brains work. A CNN is a type of AI model that's amazing at understanding images. It's the reason your photo app can automatically find all the pictures of your cat. The way it works is by breaking down an image into smaller parts and analyzing them layer by layer. It's like a digital detective looking for clues. It doesn't see a whole cat at once. Instead, it starts by identifying the most basic features, like simple edges and colors, in the first layer of its network. In the next layer, it combines those simple features to find slightly more complex shapes. So it might take those edges and colors and start to recognize things like whiskers, pointy ears, or a patch of fur. Each layer builds upon the last, getting more and more sophisticated. A few layers deeper, it's piecing together those ears and whiskers to identify a cat's face. Then it might combine the face with patterns that look like paws and a tail. It's a step-by-step process of recognition, moving from simple lines to complex objects. It's a hierarchy of understanding, where each level adds more context to what it's seeing. Think of it like building with Lego bricks. Your first step is to just look at the individual bricks, the simple, basic shapes. Then you start putting a few bricks together to make a small component, like a wheel or a window. After that, you combine those components to build a larger part of your model, like the car's chassis. Finally, you put all those major parts together to see the finished car. A CNN does the exact same thing with pixels. It starts with individual pixels, builds them into simple lines and textures, combines those into features like an eye or a nose, and finally assembles those features to declare, "I see a cat." This layered approach is what makes CNNs so powerful for image recognition tasks. They are trained on massive datasets containing thousands or even millions of labeled images. By seeing countless examples of cats, dogs, cars, and people, the network learns which features are important for identifying each object. It adjusts its internal parameters over and over again until it becomes incredibly accurate. This is why it can tell the difference between a golden retriever and a muffin, even when they look surprisingly similar. It's a specialized brain for seeing and understanding the visual world, one layer at a time. Now, if CNNs are the specialists at identifying what is in an image, then YOLO is the master of finding where everything is, and doing it fast. YOLO stands for You Only Look Once, and that name perfectly describes what makes it so special. Traditional object detection models would look at an image multiple times. They'd slide a little window across the entire picture, and at each stop, they'd ask, "Is there an object here?" This work?